Today, we're going to solve a related rate problem which are known to be applied problems where we find the rate at which one quantity is changing by relating it to other quantities whose rates are known. Our problem states that if a ladder of length 30 feet that is leaning against a wall has its upper end sliding down the wall and the rate of 1/2 feet per second, what is the rate of change of the measure of the acute angle made by the ladder with the ground when the upper end is 18 feet above the ground? First and foremost, we need to illustrate our problem to help us visualize the problem and process all information being given. This problem is a two-way process problem. In order to find the rate of change of the angle, we need to find the value of dx over dt. Since the ladder forms a right angle triangle within the wall, the second thing to do is to use the Pythagorean theorem, which is x squared plus y squared is equals to c squared. C is our hypotenuse, and based on our illustration, we already have its value, which is 30 feet. That's why we can substitute it with will become x squared plus y squared is equals to 30 squared. Equating 30 squared will give us x squared plus y squared is equals to 900. Next, we need to get the derivative of both sides. D over dt times x squared plus y squared is equals to 900. After distributing d over dx to the expression inside the parentheses, we now have 2x dx over dt plus 2y dy over dt is equals to 0. We transpose 2y dy over dt, resulting to have 2x dx over dt is equals to negative 2y dy over dt as the new equation. Based on the equation, x squared plus 18 squared is equals to 900. The value of our y is 18, and we can compute the value of our x by transposing our y value to the other side of the equation, then subtracting it to 900. 900 minus 324 is equals to 576. And then get the square root of both sides. Our x value is 24. Also, based on our problem, dy over dt value is already given, which is equivalent to negative 1/2. We now substitute the value of x, y, and dy over dt to this equation. 2x over dx over dt is equals to negative 2y dy over dt. As a result, we now have 48 dx over dt is equals to negative 36, negative 1 over 2. Multiply the numbers on the right side, 36x, negative 1/2. We have 48 dx over dt is equals to 18. To get dx over dt, we need to divide 48 to both sides. 48 dx over dt over 48 is equals to 18 over 48. Expressing 18 over 48 to its lowest term, we have 3 over 8 feet per second as the value of our dx over dt. For the third part, we will now have find the rate of our change in the angle with respect to time. In order to solve for d theta over dt, we will involve trigonometry. So we have cos theta is equals to x over c. Since cos is equal to adjacent over hypotenuse, since we already our value of our hypotenuse, we will substitute 30 from c. Next, we need to get the derivative of both sides. D over dt, cos theta is equals to xd over 30 dt. Since we already solved for the value of dx over dt, which is 3 over 8, we will substitute it to the equation, resulting to negative sine theta. D theta over dt is equals to 1 over 30, 3 over 8. Then, since negative sine theta is equal to opposite over hypotenuse, which is negative 18 over 30, and when expressed to its lowest term, we have negative 3 over 5 as our value for negative sine theta. We will substitute it and as well as multiply the terms on the right side of the equation, resulting to have negative 3 d theta over 5 dt is equals to 1 over 80. To get d theta over dt, we need to transpose negative 3 over 5 to the other side. d theta over dt is equals to 1 over 80 over negative 3 over 5. To rationalize the term, we need to reciprocate negative 3 over 5, making it 1 over 80 negative 5 over 3. Multiplying 1 over 80 to negative 5 over 3, we now have negative 1 over 48 as the value of our d theta over dt. d theta over dt is equals to negative 1 over 48. So the rate of change of the measure of the acute angle made by the ladder is 1 over 48 radians per second.